Vertical farming is a form of controlled environment agriculture. We use no natural light. It's all done artificially. But what we also do is take advantage of the vertical plane. And what that does is it increases the square foot density. So outside or in a greenhouse, you maybe have 1 or 2 plants per square foot. What I'm standing next to is 50 plants per square foot. What it also does, it allows us to grow some stuff in a region year-round that obviously don't grow in the wintertime, but wouldn't necessarily grow even in the summertime. But the footprint, as we like to call it, or the distance from the farm field or the grow floor, is really minimized. So basically what we have going on here is something that allows for a lot of reliability, transparency, and security.
A big part of this is environmental controls. This is hydroponics, it's indoor growing, it's plants, it's farming. No one does it the same. Well, our irrigation system is all hydroponic, so the nutrients are in the water. And then we use that water as our growing medium going forward. So the roots are always in the water, which allows them to uptake the nutrients in the water when they want it. You know, I don't want to schedule when the plant should eat. You know, just like I don't want to tell you when you should eat. I want you to be able to eat when you're hungry. And that's the same concept we have with our irrigation system. As LEDs advanced their technology, we started slowly switching over to that as our main lighting method. One of the benefits with LEDs is that we can control the spectrum. If we need more blue light, we can add that. If we need more red light, we can add that. Also, it's less electricity. So we went from induction, we were 840 watts per tray, and we went to LEDs, we were 780 watts per tray, and we had a greater yield. There's less electricity, a larger yield. That makes sense from an efficiency standpoint and just from good business sense. We wanted to keep the overhead low from the beginning. We also wanted the ability to take this technology out of this first world country and transfer it into second or third world countries that won't have that opportunity for high electricity demands with AC and those kinds of things. So what we tried to focus on was keeping the bad parts of outside out, which are pests, aphids, thrips, disease, botrytis, mold, those kinds of things. Keep that out while we bring in the good parts of outside, which is the air, the airflow, and sometimes the temperature, as well as the CO2. We try to have enough airflow so that our CO2 is the same thing as it is outside, the same levels. And in doing that, it keeps our costs down and the plants comfortable.
It's about science, it's about engineering, but it's also about agriculture. So if you think about what this Vertical Farm Challenge is doing, it's a very diverse group. Obviously on the blog when we answer questions, it's exciting because I've seen some ideas just from the initiation. They're going down a path that maybe someone like me who's jaded after 4 years now of vertical farming never really thought about. But it's really cool because more minds are going to make us a better vertical farming operation. But that no fear aspect is really sort of what propelled us into the vertical growing stations.
There's a lot of potential. I mean, it's limitless. I mean, it's past the Earth. I mean, they're growing plants on the ISS right now. How are we going to colonize Mars? And you got to have plants. Plants give you oxygen. We're only here because the plants were here first. You know, so if we want to go anywhere else, we're taking them with us. And this is the stepping stone, this is the foundation, this indoor agriculture. It's a bigger thing than me, it's a bigger thing than you, and it's a bigger thing than the challenge.